welcome back, folks. Today we're going to, this lesson is about division property of exponents, and we're going to use division properties of exponents to evaluate and simplify expressions. This first one right here, this first property we're going to talk about is the quotient property of exponents. And if you recall from previous lessons, quotient does mean to divide. This first property here, the quotient of two non-zero powers with the same base equals the base raised to the difference of the exponents. There's a lot of stuff going on there. Let me show you what this is saying. So we have 3 times 3 times 3 times 3 times 3. That is the same thing as 3 to the 5th power. And on the bottom we have 3 times 3 times 3, right? There's 3 to the 3rd power on the bottom. So these 3's, let me change color here for a sec. These 3's cancel out, these 3's cancel out, these 3's cancel out. And what we're left with is 3 to the 2nd power, which by the way is 9, right? 3 times 3. But there's a much easier way to do this, and that is if you just take the top exponent, which is 5, and subtract away the bottom exponent, which is 3, you get 3 to the power of 2, which is the same answer that we got up here. So that's what we're going to do for these. We're going to use this method, this much quicker way, right? So in this first example here, got 2 to the power of 7, take away the bottom exponent of 2, which is 2 to the power of 5. And 2 to the power of 5, if we simplify that, it's 32. This one, we have x to the power of 4 minus the 3 of the bottom exponent, right? There's the 4 and the 3, and 4 minus 3 is 1, which you could just write as 1. For this example here, we need to simplify this bottom first. So we get d to the 4th, e to the 3rd, and on the bottom is going to be d squared, e squared, right? This exponent gets multiplied to both the exponents on the inside. This is one of the properties, product properties. Power of a product property from one of the previous lessons. So then, another way to think about this, if you don't like the subtraction method that we used over here, right? Another way to think about this is we have more D's, right? If you look at these D's, we have more of them on the top, right? How many more? Well, you can see we have 2 on the bottom and 4 on the top. That means we have a total of 2 D's left over, but they would be left over on the top of the fraction. And we have more E's. Where do we have more E's? Right? Look at these E's. There's 3 on the top and there's 2 on the bottom. That would leave an E left over on the top. And since there's nothing left over after that, this is our answer. D squared times E. All right, take a look at this one. Take a look at the 3's. We have more 3's, right? Where we have more 3's on the bottom than we do the top. There's actually 2 3's on the bottom and 1 on the top. That leaves 1 3 left over on the bottom. Next, let's take a look at these 4's. There's more 4's on the bottom, right? There's 3 4's on the top, and there's 4 4's on the bottom. That leaves 1 4 left over on the bottom. Now let's take a look at the 5's. There's more 5's on the top. How many more? We can all see that that's going to be 5 squared, right? 5 to the 2nd power. Okay, let's take a look at the next example. This time we have 2 scientific numbers, and we're going to divide them. So this right here, the symbol is division, and that means that this whole first scientific number is being divided by the second one. 6 times 10 to the 6th power. And what I suggest you do here is you break this up to two different division problems. That's one, and there is the other. So 3 over 6 times 10 to the 10th divided by 10 to the 6th, which is equal to 3 over 6. This number right here, the top number could be divided by 3, which is 1, and the bottom number could be divided by 3, which is 2, times 10 to the power, and these exponents right here, it's going to be 10 take away 6, which is 4, which is equal to 0.5 times 10 to the 4th power. And we need to move this decimal over one place to put it in scientific notation. So it's going to be 5 times 10 to the 3rd. It decreases by 1. All right, let's take a look at this one. So this time, let me change color here. This time we have the first number, 3.3 times 10 to the 6th power, divided by the second number, which is 3 times 10 to the 8th power. Remember what I just said? We want to break this up to two different division problems. 3.3 divided by 3 times, and then we got 10 to the 6th power divided by 10 to the 8th power. And 3 goes into 3 one time, and 3 goes into this 3 one time. 1.1 times 10 to the 6, take away 8, is -2. There's our answer. All right, next we got a word problem. The Colorado Department of Education spent about $4.408 times 10 to the 9th dollars in fiscal year 2004-2005 on public schools. There were about 7.6 times 10 to the 5th students enrolled in public school. What was the average spending per student? And then we need to write our answer in standard form. So, when I see what was the spending per student, this right here is a fraction, right? Spending per student, which is equal to how much they spent, dollars. Oof, let me change that. That's dollars per student, right? And we could see up here how much they spent. So this, on the top of this fraction, is going to be 4.408 times 10 to the 9th. And the number of students, which is going to go in the bottom of this fraction, was 7.6 times 10 to the 5th power, which is equal to. And just like we did in the previous problem, we're going to break this up to two division problems. Make this much easier. So you type in your calculator 4.408 divided by 7.6, and that gives you 0.58 times 10 to the, and what do we do with these exponents right here, folks? Right, subtract them. So 9 minus 5 is 4. And we're going to move the decimal over 4 places to put this in standard form. So 0.58, 1, 2, 3, 4. Put zeros here. So they spent $5,800 per student. All right. Well, spending has gone up since then, right? This is 2004, 2005. All right. Next property we have. Positive power of a quotient property. A quotient raised to a positive power equals the quotient of each base raised to that power. So in this example right here, we have 3/5 to the 4th power. That would be 3/5 times 3/5 times 3/5 times 3/5. All right? And on the top, if you multiply straight across, you get 3 to the 4th power divided by 5 to the 4th power. A much easier way to do this is to just raise each one of these to the exponent that you see on the outside here. All right? Much quicker. So if we look at this one, we have 4 squared, 7 squared. 4 squared is 16, and 7 squared is 49. Take a look at this one. The 3 gets raised to the 4th power. Multiply these exponents together, which gives you 8. E to the 4th power and F to the 4th power. You could take this one step further, and 3 to the 4th power becomes 81. D to the 8th, E to the 4th, and F to the 4th. All right, this one down here, we have to take care of this first. So when there's problems like this where you have parentheses inside of parentheses, you always want to start from the inside and work your way out. So I'm not going to do anything to the top part of this fraction, but the bottom here, this 3 is going to raise the x to the 3rd power, and it's going to raise the y to the 3rd power. This whole thing is being raised to the 2nd power. All right, so I'm still working on the inside of this fraction, and I'm looking to see if there's anything else I can simplify, and I notice that I have x to the 3rd divided by x to the 3rd, which cancels out. So now I have this here, which is equal to 2 squared, y to the 2 multiplied times 3, that's going to be 6. And 2 squared, by the way, is 4 over y to the 6. That's our answer to that one. All right. Let's move on. The next one we got here is a negative power of a quotient property. A quotient raised to a negative power equals the reciprocal of the quotient raised to the opposite. In this case, would be positive power. So reciprocal means flip upside down, right? So I see 2 over 3 here. So when you flip it upside down, the 2 is going to be on the bottom, and then 3 is going to be on the top. To the positive 4th power, which is equal to 3 to the 4th over 2 to the 4th. Which, by the way, 3 to the 4th power is 81, and 2 to the 4th power is 16. That's good enough at that point. This one, flip it upside down. 4 goes on top, 3 goes on the bottom. All raised to the 3rd power, which is equal to 4 to the 3rd over 3 to the 3rd, which is 64 over 27. This one, flip upside down because we have this negative sign here. So it's going to be 2x squared, and on the top is going to be y to the 3rd, which is equal to, and this is all raised to the 2nd power now, which is all raised to 2. So I take this 2, then multiply it to the 3 there. It'll be y to the 6th power divided by 2 to the 2nd, x to the 4th, which is equal to y to the 6th, 4x to the 4th. Okay, this one here, I got to flip both of these fractions, right? They're both raised to negative exponents. So this first one's going to be 3 over 2, and now this is going to be to the positive 2nd power. This one's going to be 2n over 6m, and now that's raised to the positive 3rd power, which is equal to, this one's going to become 3 squared over 2 squared times 2 to the 3rd, n to the 3rd, 6 to the 3rd, m to the 3rd. All right. What can we cancel out of here? Well, I notice that 2 of these is going to take 2 of those out, right? And what's that give us? That gives us 9 times n to the 3rd power divided by This is going to be 36 times 6, m to the third. The reason why I wrote 36 here is because 9 can go into 36, right? 9 can go into 36 4 times. So let's cancel that out, which is equal to n to the third on the top, and on the bottom we have 24 m to the third. There's our answer there. Okay. That's it, folks. This is everything there is with division property of exponents. Next, I'm going to give you a lesson quiz. Remember, you can press pause and try to work on the problem, see if you get the correct answers. All right, here we are. Let's check to see if we learned anything, put into practice what we went over. And remember, the best way to get better at math is to keep doing math, just like anything, right? Better at baking, you gotta bake. To get better at basketball, you gotta play basketball. Try these problems, see if we get the right answers. You can press pause in 10 seconds. You gotta put the answers up right about now. Okay, here's the quiz with your answers. Check them out, see how you're doing. If you got wrong answers, go back and try to check and see what you did wrong. All right, folks, until next time, keep those pencils sharp and keep plugging away.